Hey, what's up guys? It's Evan, and today we're going to be looking at building a simple ARKit application with React Native and THREE.js. This one is going to be very exciting. As you can see by this demo, it's just some crazy technology we got going on over here. I'm not going to get too much into using THREE.js in Expo or React Native. I'll have another video on that, and if you aren't familiar with THREE.js, I would recommend that you check it out. A lot of the same stuff is going to apply to this video, and yeah, we're basically just building off of that and adding AR. AR is so easy to use in Expo, it's ridiculous. Let's look at a little bit of what we got. I'm going to use one hand and just kind of hold it up here the whole time, and try not to... Yeah. Whoa. Alright, so let's take a look at this demo that we've got going on over here, and I'm going to play with it like the child that I am with the screen recording. So you see we've got an AR scene in a React Native application, and it's using expo-GL to convert this THREE.js WebGL application into a native ARKit application. And then we're using a library called expo-three, which just helps us do some of that binding. And using this stack is the only way that you can write a native THREE.js AR application. It's very specific, but there are a lot of other kind of pseudo solutions that don't work nearly as well. So it's a lot of good stuff going on here. And then there's also a lot of helper things built in. Like if I were to cover this up, you'll see it says insufficient features. Try moving the camera around. Or if I move too fast, it will be like excessive motion, at least until you shake out of the Expo thing. It'll say excessive motion, like stop moving your thing. So it'll surface all this native AR information to your user as you use the application. You can turn that off if you want. I always like to have it on because it's very convenient. Now I should mention that AR in Expo currently only works in iOS. There's a PR open to get it out working with Android, and that should be in there any day now. But at the time of filming this, it's just going to be iOS. So yeah, just something to keep in mind. Let's go ahead and look at the source code for this project. And links to all this will be in the description, along with some documentation and other accompanying documents that I might add. Very basic, what we've got going on here is a component, React component, and in the render method we're returning a graphics view which we import from expo-graphics, and this graphics view wraps the expo-GL view, and then it also does a few other AR things for us. So we have this graphics view, and then we have a flag here that we're enabling by doing is AR enabled. Now doing is AR enabled is the same as doing is AR enabled and then equals true. If you just omit that, then it just passes this value in as true. And then we have our onContext create and our onRender method, which I get into more detail in the GL THREE.js video, whatever I end up calling it. I just filmed it a second ago, so it's not actually out yet, but I recommend you check that out if you're not familiar with what these functions do. Basically, we're passing in a WebGL rendering context, and then we're going to create a THREE.js scene from it with renderer and scene and camera. But we do things a little differently because in an AR app, you need three things. Those three things are actually two things. They're the camera and the device orientation. So the camera is what we're using to create this background texture here that we can render to make it look like our 3D scene is in the real world. And then the device orientation, we're mapping that to our 3D camera so that if we move our device, it lines up our 3D camera with that device so that it makes it feel like we're in a 3D world. And then we can do a few other things to be even cooler by like what we've got going on here where we're actually mapping the cube to a surface as opposed to arbitrarily moving around it, which maybe I should do so that you can see. It's getting real jittery because I'm being crazy. You catch a glimpse of my suave cardigan that I've got going on. I'm having way too much fun with the camera in this episode. In our onContext create method, we're using this method ar.setPlaneDetection, and then we use ar.planeDetection.horizontal. Now in ARKit 1.5, which Expo version 29 supports, you can do horizontal or vertical, and then in ARKit 2.0 you can do both. So that's not supported yet, but you can do most everything with horizontal. Now we're going to create a render the way we do with any THREE.js app. We're going to create a scene the way we do with any THREE.js app. But what we want to do is we want to set our background to a background texture, which we're creating from THREE.AR. So we do 3ar.background texture, and we're going to pass in our renderer, and this is what will create the background. If I were to comment this out, which I won't do because it might break everything, then there will just be no background texture, and we'll just be moving arbitrarily around a cube. And then after that, we've got our camera. Now, in any Three.js app, we may create a perspective camera. I mean, we more than likely will create a perspective camera. So what we've got going on over here is this 3ar.camera, which is actually extending a perspective camera, but we're going to give it an extra update method, which will allow us to make that camera sync up with our phone. I'm running out of words here. It'll sync up with our phone so that we can move around the object. And then everything past this, for the most part, is just generic Three.js stuff. We've got geometry, material to create this red cube that we've got going on here. And then we're going to add the cube to something called the magnetic object. So this is a little thing I coined. What the magnetic object does is it does a ton of calculus and math and geography behind the scenes so that we can map we can map all of the raw data that's returned and hit testing data into an object which sticks to surfaces. So the reason for this is because sticking to surfaces is actually pretty difficult. It requires a lot of just extra code setup. But what we've got going on here is we create a magnetic object, and then we can add any kind of node that we want to it. So for this example, we're taking our cube and we're adding it to the magnetic object. Then we add the magnetic object to the scene, and that enables us to stick our cube to surfaces. And then we're going to add some basic lighting over here, just an ambient and a directional lighting so that we can actually see the cube. And then in our renderer, what we're going to do is we're going to update that magnetic object by passing in the camera and then passing in the position of the screen we want it to stick to. So you notice it's stuck here to the center of the screen. That's because over here we're passing in 0.5, 0.5. That's a relative position saying middle of the screen. If I pushed in like 0, 0, then it would stick up here or it would stick down here. So just things to keep in mind, lots of little customizations you could do. And then we're doing the standard render.render, which will composite the scene and the camera into the image that we're seeing here on our device. So like I said, not too complex, or at least it wasn't for me, but I wrote a lot of the library. Maybe it's very complex and I'm just ignorant now, and math and geography behind the scenes. But anyways, guys, that is it for today. Thanks so much for watching. I hope you enjoyed. If you did, be sure to leave a like, comment if you have any questions or concerns. A link to all this code and the documentation will be in the description below. And yeah, have a lovely time until you see the next video that I will be in. That's my way of saying it. I'll see you in the next video. Bye. And then, you know, we can look around my messy room at my Chips Ahoy and my microphone that I'm sitting too far away from, and all these ominous, creepy locks that I have on my table. I'm a weirdo.